bit later you can see this. If we add two operations together, we can return all ages in the image. As you can see, it was the first image, and we return this image by using Sobel operator or Sobel filter. It returns the ages. But actually, you can use some other algorithm for the age detection. That the best one is a Canny. You can use, but Sobel is cheaper than Canny. But in some application or offline application, you can use Canny age detection instead of Sobel age detection. Another method that we can use to age is a fast binary filter. Actually, if we xi diagonal matrix is defined to be a symmetric square matrix, psi k multiple k xi, which has value 1 on its xi diagonals and 0 on the remaining member. As you can see here, it's a psi matrix. The size of the matrix is, we can write it here, k by k. For example, we have the 7 by 7 here. In the case of the I minus j, absolute value of the I minus j is less than or equal to xi, you can write 1 in the matrix, and otherwise you have to write 0. And you can see we have the 5 as a xi, and you will see that we have the 5 diagonal, the diagonal in the center, this, and this. If you change, for example, this to 3, you just have this one and this one. And also, it depends on your application, you can change the value. But if we multiply that matrix to the image, for example, if you consider our input image as a n by n, the size of the or image, and size n by n, you can see that we find this matrix, we can find this, and also if we multiply the psi matrix by the transform of the image or the transform of the matrix, you can find another matrix that's here. If we add these two matrices together, and you know they have the same dimension, and you can use the transpose of one of them. In this case, we use T. Then we can return some edges. You can see a block diagram of this method. It's a binary the noise. We add some salt and pepper noise. We can add salt and pepper noise to the image. Then we multiply the image by psi matrix, and also we multiply the transpose of the image by the psi matrix, and we find the new matrices. We add these matrices together, transpose of the second one, and we can find the edge detection method. That's the multi-diagonal matrix multiplication. Here you can see it's the original binary image, it's the corrupted image. We add some noises, for example, you can see here some black and white noises. We find this value after applying the kernel, and if we use some threshold for the image, we can exactly return the original image by using this method. Yeah. And also, if you want to know more about this, you can find the code of the function here. We can go to this link and let me you can go to this link and download the code from Mathwork website and use for your application. And was the thing that we talked about is how we use the spatial domain filters. Some of the filters described on yesterday, and some non-linear filters that you see the Laplacian or Sobel or something like this. We know it today. We know that what's the mask, what's the kernel, and how to operate the convolution and correlation, how to use the Laplacian gradient, and how multiply diagonal mask operator work. And starting from the next week, that we talk about how we talk about this, we will talk about image enhancement in the frequency domain. And that's it for today. Thank you for your attention.